Hi sir, this is Emily and I'm going to do my velocity observation questions. Hi sir, so first I'm going to read through the whole question and get the information. So after I read the question, I found out that the air velocity of the plane is 160 kilometers per hour with direction south 67 degrees to west. So I use vector VA to represent the air velocity and its magnitude should be 160 kilometers per hour. So also it has a west wind of 60 kilometers per hour, so I use vector VW to represent the wind velocity, and its magnitude should be 60 kilometers per hour. So because I want to draw a really accurate graph here, so I have to find the ratio between these two magnitudes, and after calculation I get their magnitude ratio should be 8 and 3, so I'm trying to use 6.5 centimeters to represent the magnitude of vector VA, and approximately 2.4 centimeters to represent the magnitude of VW. So now I'm going to find out my ground velocity, which I use vector VG to represent it. So because it's actually it's addition of vector VA and vector VW here, this formula here, and also their tails are attached, so I'm trying to use a parallelogram to find out my vector VG. So first I had to draw a dot line that parallel to vector VA and the dot line here to parallel the vector VW. So after doing this, we make a parallelogram and we had to ensure my vector VG's tail should be attached to the other tails, and the head should be at the opposite corner of the parallelogram here. So I get this arrow. So this is my vector VG here. So after I draw it, I had to find out my angle beta here, which is really important for my calculation later. So because it's a parallelogram, so the angle here and here should be the same, and these two angles should also be the same because of the property of it. So I calculate beta is also mean I calculate this angle. So I use 180 degrees to minus bracket 67 degrees here to plus this angle 90. So I will get this angle as well the beta. So it's 23 degrees. Okay, so I can label all my information this side. Okay, so I'm now going to find the magnitude of my vector VG. So basically use this formula here is a cosine law. So you can see in this triangle, I'm using this triangle now. So the opposite angle of this vector VG is actually here, 23 degrees. So I put 23 degrees here after the cosine, and put the other two sides inside this formula is 160 and 60 here. So after calculation, I get it magnitude approximately equals to 107.4 kilometers per hour. So I get my vector VG's magnitude, and now I'm trying to find direction of it. So this time I'm using this triangle here, this triangle, instead the yellow one. So I have to know all of the sides of it. Yeah, I know it. And I want to get my angle alpha. So how we get it? We have to use 67 degrees, this big blue here, to minus this little angle theta to get my angle alpha. So first I'm going to find out the angle theta. So its opposite side is 60. So I write 60 first, and the other two sides 160, and the magnitude I just calculated here. So put all of them inside this cosine law. Why use cosine instead of sine? Because if we use sine law, we have to consider the ambiguous case, but I don't want to consider it. I'll ignore it. So I use cosine instead. So after calculation, I get my theta approximately equals to 12.6 degrees. So I can get my alpha here. Use 67 degrees minus my theta. So equals to 54.4 degrees. So I get my conclusion. Therefore, the ground velocity is approximately equals to 107.4 kilometers per hour. So this is also the magnitude of it, with direction south 54.4 degrees to west, because it's south 54.4 degrees here to west, because it's from to west, right? So it's this angle alpha here. So that's it. And thank you for this.